In this recording, we are going to talk about compound decision structures or compound if statement expressions. So we have a couple of additional operators, the double ampersand, the double pipe, which is the key over the enter if you hold in shift, and the caret that we'll go into in a little bit. We're going to start with this. Basically, with a compound Boolean expression, I have multiple individual tests that I am testing for. What's going to happen is each of the individual Boolean expressions is going to be solved, and then they're going to be combined or simplified down further. When I'm in class, I usually do something along these lines. We see I have A set to 1 and B set to 2 on lines 11 and 12. As the computer goes to break down line 13, we'll solve each individual expression first on its own. So A is equal to 1. This is true. On the next pass, the computer would do, we would solve the second Boolean expression. B is equal to 3. Well, as we can see from line 12 here, this would be false. Once we've solved all the individual expressions, Java is now going to use my Boolean AND operator to solve this down to an individual true or false value. Basically, this is the AND operator. It means the Boolean expression on the left has to solve to true, and the Boolean expression on the right has to solve to true. True and false is going to simplify to false. Oops, that's not what I meant to do there, but let's just overwrite it like this. This is what the overall result of that expression is going to be. Okay, so I'm going to take this out. Okay, I like to solve this by showing you how the individual parts are solved and then how we combine the end result with and or. So again, we're doing ands here. Again, in this example, this is true, but this is false. So true and false is going to give me false. So I expect this to write out false. Now, you can see my IDE here is griping because it knows just by looking at the hard-coded values that we're never going to run the true clause. But that's okay. This is just for demonstration. And as expected, I got false. When we're learning about these Boolean logical operators, as we call them, we usually have to learn what we call our truth tables. So let's review the truth table that I have typed up here for and. A true value and a true Boolean value, when used with and, will give us true. True and false would give us false. False and true would give us false. And then false and false would be false. Okay? With and, both operators have to be true for the expression as a whole to simplify to true. Now let's change this operator to or. With or, only one of the expressions has to evaluate to true, or simplify to true, as we say, for the entire expression to simplify to true. So once again, I'll just copy and paste and demonstrate solving one expression at a time. Okay, so here we have A equals 1. That would simplify to true. B equals 3. Well, as we can see again from line 12, that would simplify to false. B is not equal to 3, it is equal to 2. But with or, only one of the individual Boolean values has to be true for the system as a whole to combine to simplify to true. So the end result of this, if we're just working it out in code form, the end result of this, true or false, would be true. Okay, I'm going to take out that demonstration code right there, and let's run this and see if it behaves as expected. And I did get the expected true from that result. So our truth table for or, true or true is true, true or false is true, false or true is true. And then finally, false or false is false. Finally, we have the exclusive OR. With the exclusive OR, sometimes written as XOR, the expression is true if only one of the sub-expressions is true. So let's work this one out and see what we would get. Okay, well, my indentation didn't help there. Okay, A equals 1 would be true. B equals 3 would be false. And with the exclusive OR, if only one of those two things is true, then that's going to simplify to true. Okay, so let's run this and see it in action. I expect right now, once again, oops, let me get rid of that. Once again, I expect right now, this is true, this is false. I expect to see true being written out. And I did see true. Let's make it so this would be false. I'm going to test to see what happens when I run something that is true here and something that is true here. And I get my false, as expected. So the truth table for XOR, true XOR true is false. True XOR false is true. False XOR true is true. And false XOR false is false. Now, by the way, I'm writing these in the most simple way that I can in order to keep the videos brief. I have a different file over here that might be a little bit more normal that you'd be writing. So here, I'm going to ask the user to enter their age, and I'm going to enter 15. Okay, so, well, age less than 16, that's obviously what ran because we entered 15. But a more realistic use of this would be to test for numbers within a range. Okay, so here's where I might compare age twice. First, seeing if it is greater than or equal to 16, and also if it is less than 21. And if both of those things are true, then we print out the string, you can drive but not go out on the town. Okay, so I'm going to enter 16. Okay, we'll run it again with 21. And I want to point out, I intentionally left a mistake. Not a mistake, well, a common mistake, but not one that I made in the process of coding, but one I put in there for the process of demonstration. When you're writing your if statements, you kind of need to think about what different possibilities you might bump into. If I'm asking the user to enter a number, well, their age could be less than 16. It could be greater than or equal to 16, but less than 21, or greater than or equal to 21. These three options pretty much cover the entire range of potential values the user might enter. This else is basically useless. This else will never be reached if the user enters a number. So technically, we could just completely clear it out. Okay, so let's run this again. And I'm going to enter 18 this time. Okay, and one thing that I want to point out, if you're doing things like, oh, you're going to build a letter calculator, user enters a grade, 85, it should say you got a B. Okay, if you're doing that, you have to consider your ranges very carefully. A lot of times I see people doing things like this. If age is less than 16, we'll print out you can't drive. If it's greater than 16, we'll print out you can drive but not go out on the town. So I'm going to go ahead and run this, and we'll do 17, and I get the expected you can drive but not go out on the town. However, if I run this again, and I enter exactly 16, nothing happens because the value 16, well, age wasn't less than 16, nor was it greater. So it is very common. You'll have to be very careful with your ranges in here, making use of some form of less than or equal to. I might have made the same mistake here if I didn't do the less than or equal to. Well, right now, what happens if the user enters 21 exactly? Nothing's going to happen. Okay, again, that's because I didn't account for all the potentials. Okay, so let's put that equal sign back in there. Okay, hope this was helpful.